Okay, so our next one's going to be an example of how to calculate empirical formulas. So for this one, you're going to be given percentages. For an easy one, you start off with percents. So we're going to start off by saying that we have 26.56% of a compound that has potassium, and then it has also 35.41% of chromium, Cr, and then we're also going to say that it has 38.03% of oxygen. Okay, so given these percentages, from here what we need to do is, like we did in the other calculations, we're going to go ahead and start with our first step, which is divide them by their atomic masses. So we'll set them up in a line over here. So that'll be 26.56 for K, and then Cr, we write it out over here, that's 35.41, and then oxygen is going to be 38.03. Okay, so at this point we need to divide by the atomic masses. Okay, so if we look at the periodic table, we got to look for potassium first, which is on the left side over here. That has atomic mass of 39.10, so I'll put that here, 39.10. Chromium, which is over here in the middle, that has a number, or average of atomic mass, excuse me, of 51.99. So we'll put that right here. And then oxygen has one that we're familiar with, that should be 16 even. Okay, and at that point, once we do that, we then divide and we see what decimals we get. And so after you do it in the calculator, this should come out to 0.68 roughly, and you round to the nearest hundredth. And then this also comes out to 0.68, and then this one comes out to 2.38 when it's rounded. Okay, now remember, the next step is to divide all of these by the smallest one. So these are, the smallest one here is 0.68, so we'll divide again by 0.68, 0.68, and 0.68. And now we're going to get some that are close to whole numbers. So these two are pretty clear. That's a 1. That's a 1. And then over here, 2.38, when you type that into the calculator, gives you roughly 3.49, some such other decimals. But because we're doing empirical formulas, we can round that, so that's going to be 3.5. We're not going to round too much. We want to keep it to either the 0.5, the 0.25, or the 0.75. So the final step here is to then multiply these to a factor where they're all whole numbers. You can't write down K1, Cr1, O3.5. Okay, you need to have whole number mole ratios. So we're going to multiply these all by the same number to get this one to round off. So the next way you can do this is by doubling it. So we're going to double that, and double that. So these pretty much stay the same. So that's 2, that's 2. And now we end up with our O being a whole number of 7. So our empirical formula here are these new whole numbers. So this should be K2, Cr2, O7. And remember, empirical formula is just the simplified version of this chemical. So this might be something that's actually K4, Cr4, O14, but this is the empirical formula. It's the most simple version of this. Just depends on what we're talking about, and we'll show you that in the next one for calculating molecular formulas.